All right, welcome back. So in our last screencast, we set up parts 1 and 3 of our shortest route problem. Here, I'm going to work on part 2, which is going to take on a slightly different form. All right, and so for the case when we had $0 transfers between our airlines, so I don't want any routes in which the price is zero. Just in terms of working with those variables in my objective function, right? Anything times zero is zero. Um, and so what I'm going to do here is we're going to have a slightly different setup when we have a cost for transfers. Okay, but let's do it. Okay, so let's go over the problem again. We can kind of look at what we had from last time in terms of our network, and then we're going to have to draw a new sketch for this problem and reset up and solve. Okay, so the problem is still straightforward. It's just there's more bookkeeping for us to do. All right, so here we go. So I'm planning a trip from city A to D. Flights are available from 3 different airlines, X, Y, and Z. While a direct flight is available on airline X, flights are also available to cities B and C. And then parts 1 and 3, transfers may be made for $0. Okay, well here we're going to work on 2, where we want to find the least expensive route from A to D, but we're going to assume that we have transfers of $50. Okay, and so here is my sketch from we started in 1 and 2. We're kind of this idea of we're starting with a single destination in which the cost is essentially $0, and then I can leave A in any one of my airlines. My goal is to get to some common destination, and we had $0 exchanges. All right, and so what we did in that case was we essentially consolidated our network to have a single node A, B, and C. And then when we had multiple flights on the different airlines from a given origin to given destination, we consolidated them. All right, so what we're going to do here is I'm going to redraw my network, right? And how I'm going to redraw my network is rather than having these 3 separate node A's, okay, I'm going to lump them all into a single network A, okay. But then I can go from A to other whatever destinations I'm leaving A from on flight from a different airline. Okay, so I'm going to consolidate my A's. Then likewise, I'm going to consolidate my B's. Okay, and then what we'll do is when we're at B and C, we'll add in routes allowing for the changing of airlines. Okay, so I can go from X to Y, X to Z, Y to Z, and vice versa. So I'll have to have routes which can go both ways to allow for the exchange, where the exchange is in all case $50. Okay. So I'm going to draw up a new network that'll look a little more complicated than what we had last time. But now we're going to want to keep all routes because it may be that a route that we had eliminated before because it was more money might be more advantageous this time when it might have cost maybe I would have to transfer from another airline, which would tack on an extra $50. Okay, so the first thing I'm going to do is I'm going to come up with a new sketch. Okay, and so in this new sketch, okay, I'll draw it a little bigger. I'm gonna have some common origin node A. Okay, and then in B, okay, I can have a B, and I'm gonna call it BX. Right, I can get to B on airline X. I can get to B on airline Y. I can get to B on airline Z. Okay, likewise, I can get to C on airline X. I can get to C on airline Y, or C on airline Z. Okay, and then I'm going to get to this common destination D. Okay. All right, so now if I let's go through this again. So from airline A, let's look at all of our flights. Okay, so from A, I can go to B on airline X. Okay, and that cost is $160. So I can go from A to B so that's 160. Okay, and actually I'm going to drop the $sign so this doesn't get too complicated. I can go from A to C on airline X. That's $90. Okay, and then on airline X, I can actually go from A to D. That's our only flight from A to D. All right, and so I'll be able to differentiate that one. Okay, and that's $400. All right, and once I set it up, I'll see if all these variables make sense and work out for me. All right, then I have, okay, that's airline Y, so that, or X, so in airline Y, I can go from A to BY, the cost of $170. I can go from B to C on airline Y, so it'd be BY to CY, that's $50. And I can go from B on airline Y to D, and that cost is $80. And that takes care of airline Y. Then airline Z, I can go from A to C for $140. I can go from C to B, which is $30. And I can go from C to D for $160. Okay, now come in all of our potential transfers. Okay, and I'm going to draw my transfers in red just to make them clear. Okay, and while up here I use single arrows. We can keep single arrows. I'm going to draw double arrows for clarity though. Okay, so if I start in city B, right? So now I'm in the B airport. Maybe these three different airlines arrive in three different terminals. So within B, so essentially to go from BX to BY, to go from airline X to Y, that's, I said I'd get rid of the $sign. That's, and actually, let's draw them all, then let's write the 50 on, because if it's too complicated, I'll just say red's $50. Okay, so I can go from airline X to Y or Y to X. I can go from Y to Z and Z to Y. And I could also go from X to Z and Z to X. Okay, and let me just write in general. Remember, all these red routes are $50. Okay, then likewise in city C. So if this is the C airport, I can go from X to Y or Y to X. I can go from Y to Z and Z to Y. And likewise, I can go from X to Z and Z to X, where the cost of all of those transfers is $50. Okay. So now I have my complete network, where hopefully within B and C, these additional designations of X, Y, and Z can help me differentiate between the airlines. There's only one flight going from A to D, and so if we end up taking this route AD, we'll know that's on airline X, since that's the only one. Okay, so this is still a straightforward network problem. It's just we're going to have more variables, right? We're going to have more variables because we're not eliminating any flights like we did in part one. And now I'm going to have all these extra variables corresponding to each transfer. And what is that? That's 2, 4, 6 in each case. So that's an extra 12 variables, which are just essentially these transfer routes. Okay. And if I have a, say X, CXCY is 1, then I know I'm going to transfer from X to Y at that point. Okay. So let's set it up, right, and see how it all goes. Okay. So my first thing is, let me list out my variables. Okay. Okay, and I'm going to kind of differentiate them just to kind of keep track of things in myself. Okay, so I'm going to have airline X, Y, and Z. Okay, and then I'm going to have my transfers in B and my transfers in C. Okay, I just want to try and keep track of all these as I list through them, right, to make sure I get them all. Okay, so in terms of airline A, right, so again, I'm going to have A to B, A to C, and A to D, right, where B and C I designate with this X. Right, and I could even get that from this top diagram. Okay, so my variables are going to be written as X, and then I'll have my origin, which will be A, and then BX, X, A, CX, and XAD. Okay, this could be our only XAD variable, so we'll be able to distinguish how we're if we take that direct route. Okay, Y. Okay, so we have it here. It can also go up to the top picture. On Y, I can go A to B, and then B to D, and B to C. So I'll have XAB on airline Y. Then we have BY to BC, or XBY to CY. So okay, so on airline Y we can go from B to C or B to D. So that's X, B to C on airline Y. Boy, sorry, this naming. And then we can go from B to D, right? Where it's just D because it's the common D. Then on airline Z, we can go from A to C. Okay, A to C. Then we have C to B, C to B, and C to D. Phew. Okay. So let's see, each airline has 3 flights. All right, that's good. So we have 9 total flights listed. And then transfers. All right, so we're going to have 6 transfers. Okay, and so we can enumerate over all of these essentially. But in transfers in B, I can go from X to Y. I can go from X to Z, and I can go from Y to Z, okay, and then I need to get the reverse. So then I can go from Y to X, Y to X, Z to X, so this is supposed to be BZ, BZ, BX. Okay, so X to Y, X to Z, Y to Z, Y to X, then we have Z to X and Z to Y. So we have Z to X. Come on, this is where I'm messing up my own notation. And Z to Y. Okay, phew. 2, 4, 6. Got it. Okay, and then for C, we'll just write them down, but change the B's to C's. Phew. All right, so there's all my variables. Good. Okay, now let's write down our constraints. Okay, so we're going to start with this general sense. Okay, so constraints. Okay, and so let me just start in general. So I am not going to write down all of these variables, right? But our essential constraint is our variables are going to be 1 if a route's taken, 0 if it's not taken. Okay, and so in Excel you could just indicate that your variables are binary, or in the general case, it's going to be that our variables are greater than or equal to 0, which is our non-negativity constraint. We'll have that our variables are less than or equal to 1, and then we'll have our constraint that our variables are integers. Okay. Next, okay, we'll just keep working on constraints. I'm going to add our constraints. Okay, and here I'm going to work on our node balances. Okay, so by our node balances, essentially that's going to be, in is equal to out. Okay, and how we're going to set this up is we want to start at node A and end at node D. Okay, so we can add another color. We're going to have some, where's my pen? Oh, over there. So I'm going to have, some fictitious unit, I guess in this case a passenger, entering at node A and exiting our network at node B. Okay. So let's do it, right? We're just going to have to go step by step. Okay, so at node A, okay, and okay, let me just further deconstruct this. We'll have a balance on A, node A, B, C, and D. Okay, so at node A, so I have that one unit coming in. Okay, and what's coming out? So I have 1, 2, 3, 4, 5 exiting flights. I have AD. So XAD. Okay. What other flight do I have? I have a CX and a BX. So I have a flight to B on airline X, and I have a flight to C on airline X. So that takes care of the first 3. Then I have A to B on airline B. A to B on airline Y. And then I had A to C on airline Z. Alright, and that should be my 5 flights. My 5 flights leaving A. Good. Okay, now let's get to B. B is going to be a little longer because now we have all of these transfers. Okay, so let's start with in. So what's going in? Well, let's just look at flights first. All right, let's list our flights going into B, and then we'll list our transfers going into B as well. So flights going in are going to be ABX, ABY. Okay, so flights in from A are ABX and ABY. Okay, XABY. So flights into B. The 2 flights into B from A. Are there any other flights into? And I take it back. I've got to go. I've got to break this up a little bit. Okay, I was a little too trigger happy. So in terms of nodes, oops. So, hold on. Now I lost one. I don't have nodes B, C, and D. I have BX, BY, BZ, CX, CY, CZ, and D. So I need to write them all down. So in terms of flights out of um, A, B, Y, then it was A, C, Z. CZ was what got erased a little bit. Okay, so I goofed up. So it's not just B. We've differentiated. So we have BX, BY, and BZ. Okay, and then we have CX, CY, and CZ, and then we just have D. Okay, good. All right, so now let's get started on BX again. Right, I just want to look at BX because BX now I just have one flight coming in, and that's from A. Okay, so in is XA BX. Okay, so that's flights in. Okay, now do I have any transfers in? Do I have any red arrows in? I could transfer in from Z and Y. Okay, so coming in, I have this would be XBZBX and BYBX. So I can transfer in from Z or Y. So this would be, I could transfer in from Y, or I can transfer in from Z. Okay, so there's all my ins. Then what is going out? Okay, so exiting, I have, I have no flights. So if we start with flights, there's no flights exiting BX. Okay, so that's good. But I have transfers. So I have X to Y, and I have X to Z. All right. So the same two that could transfer in can transfer out. All right, so it makes sense if I took that flight from A to B. Well, then I'm kind of stuck there unless I transfer airlines. Okay, and we're going to repeat when we go to BY. And I just want to make a note. Remember, before I was kind of complaining about when the price, say if a transfer was $0 and included in my network. All right, so that $0 wouldn't affect my constraints, so my mole balance would still be the same. So in theory, what we're doing here, I could have done in part one and part two with my $0. Right? It should work because we're going to have the same balance. We have these node balances that all be the same. My objective function, those variables wouldn't be included in the objective function because they'd be, 0. It's just the way we set up part one and two is a lot easier. This is going to take me some time just to set up. Okay, so we could have done this for part one and two. The setup would have been exactly the same way, but consolidating was easier in those cases. Okay, now let's get to BY. Okay, first let's do flights coming in. I just have a flight from A coming into Y. So I have X, A, B, Y. Okay, now let's account for transfers in. I can transfer into Y from X or Z. So it'll be, X, BX, BY plus X, BZ, BY. Okay, now what's coming out. Do we have any flights exiting BY? We have two flights, one to D and one to C, so CY. So flights out, we have BY to CY, and we have BY to D, and then transfers. transfers, we're going to have by to bx, right? And in theory, I should never transfer from y to x, right? I'm going to write it down in general, right? But I should never transfer from by to bx because you can't leave bx, right? But again, we're writing this out in the general sense, so that if you wanted to, change up the airlines, you could. So by to bx and by to bz. All right, so again, so this variable should be 0. That shouldn't even be an option since I can't leave b on x. But I'm just going to write it out for completeness. Completeness being if you want to, take the same problem and just change up the routes, you could, right? That part still be the same, okay? But good. We can also use it as a sanity check, I guess, once we have this all set up. Okay, let's go to Z. Are there any flights arriving at Z? Yes, there's a flight arriving at BZ from CZ. So flights in to BZ, we have XCZ. So that's XCZ to BZ. Okay, and then any transfers in. So transfers into B would come from Y and X. Okay, are there any flights out of BZ? No, there are no flights leaving BZ. Okay, so this is another one. I would never actually transfer to BZ because I can't leave BZ. Okay, so this is another one where BX and B, the transfer from X or Y to Z should never happen. But we're just going to write them down in general, and in theory, those should be 0. Okay. All right, but now let's go with leaving Z. Leaving Z would just be via a transfer to Y or a transfer to Z. Or a transfer to Y or a transfer to X. So we can transfer out to X, or we can transfer out to Y. Okay, and again, we're writing this in a general sense. I see that Z is essentially kind of, terminal destination, right, on airline X, right? So I need to transfer out if I take that route, but there's going to be no transferring in since it'd be a dead end. Okay, now let's move to CX. Flights into CX, we have one from A. So we have X, A, CX. Okay. Then do we have any transfers in? I could transfer in from Y or Z. So that'd be X, CY, CX, CZ, CX. Okay. Then leaving CX, there's no flights leaving CX, so it would just be transfers. And so I can transfer to CY or CZ. So I would have X, CX to CY, or CX to CZ. Okay, and that's it. We go to Y. Are there any flights coming into Y? CY, yes, there's one from BY. So I have X, BY to CY. Okay. Oh, then do I have any, that's flights in, do I have any transfers in? Yes, I could transfer into CY from X or Z. So I can go from CX to CY or CZ to CY. Okay, so that's in. Okay, any flights out of CY. There are no flights out, so just transfers, and I could transfer to X or Y. So I'll have X, CX, CY, X, CY, it's my origin first, CY, CX, CY, CZ. Okay, now we get to CZ. Any flights into CZ? Yes, I have one from A. So I have X, A, CZ. Okay. Do I have any other flights in to CZ? There are no other flights in. So now it's just transfers from X or Y. So X starting in X, ending in Z, starting in Y, ending in Z. Okay, so that would be transfers in. Now let's see if there's any flights out. There are two flights out, one to BZ and one to DZ, or just D. So we'll have X, we'll go from CZ to BZ, and then we'll go from CZ to D, and then I just have to add into that the possibility of transfer. I can transfer from Z to X or Z to Y. Transfer to X, or transfer to Y. And then finally, I just have a balance on D. I have flights from A, BY, and CZ. So let's start with A. I have X, AD, plus. That's flight 1. Flight 2 is coming from BY. And then we had CZ. Okay, and then coming out is 1. Okay, so there's my system of node balance constraints. Okay, we have our general constraints and variables. So it's just as any other shortest route problem. It's just it's more involved. There's more routes. And again, we could have eliminated some routes. So say at node B, I'm not going to transfer to B from Z or Y because there's no flights leaving B, so I'd be stuck there. Right, it'd be a dead end. Right, so I know I'm not going to go there, so I could just delete them. But we'll keep them. Just like I wouldn't transfer from Y or X to Z because that's also a dead end. Okay. All right, so just to make it clear, and I'm not going to delete them because I'll just throw a little x, right? So I would never go from X to Z or Y to Z, just like I would never go from Z to X or Y to X because those are both terminal destinations. All right, so in theory, there's only two possible transfers from B to Y or Z to Y. Okay, but I'm going to include those other four in there just for completeness sake. Okay, and C, I would never transfer to X since it's a terminal destination. I would never transfer to Y since Y is a terminal destination. Okay, so I never transferred to X, and I would never transfer to Y. Right, so the only real possibilities are from Y to Z or X to Z. Right, so in both cases, there's only two real possible transfers. So we could have simplified it, but I kept them in there for the general sense. Okay, and then finally, if we want to write our objective, okay, and our objective is going to be minimize cost. Okay, minimize cost. Okay, And again, we could have done this for part one where we had $0 transfers, um, because our constraints wouldn't be affected. It's just this objective function would be affected because 0 times anything is 0. Okay, and so now you're just going to have to sum over all the variables and multiply um, by their routes. Okay, and so I'm just going to get it started, and then in the final version of the posted notes, we'll have it there. But x, so it'd be 160 xa bx plus. All right, I'm just going to look at the next variable on my variable list, a cx. A cx is 90. All right, and so on and so forth. Okay, so I'm going to stop the screencast here because it'll probably take me another couple minutes of going back and forth to write down those costs. But I'm just going to sum over all my routes, the route variable times the cost. There's my objective function. And then the next step would be to go over to Excel or LibreOffice Calc and solve. When I post this final, set of notes, I'll have the final objective function in there. But you just don't want to, watch me do it. Okay, and again, we could have set up part 1 and 3 exactly the same way. In that case, transfers just would have been $0, but our constraints would be exactly the same. It's just the 0 would come into play in our objective functions. And just like I said from this diagram, we could have eliminated it looks like 8 total of the transfers, so that were only really 2 possible at node B and C. I kept them all in there in the general sense. Solver should set them all equal to 0. And then that way, if more routes were to be added or removed, those transfer variables would be exactly the same. Okay, but in theory, from inspection, you could kill them if you wanted to. All right, hope that helps. Let me know if you have any questions.